All right, let's begin. So today, I want to cover files. Let's see here. Here we are. Let's go back to the top of this. Okay. Don't know why it's fighting me so hard to go back. Okay. Wonderful. All right. Okay. So today we are going to be learning about files. And the reason why we're going to do this is mostly because actually it was kind of on the lecture schedule, but it's also it's kind of an important topic, and we might have you do some file I/O for the second project. We'll probably have you do some file I/O for the third project. If you notice, the file input-output for the first project was done for you in load board, or whatever that function's called. The idea here is that, you know, it's not actually very difficult if you look at the code. It's not very long. It's just that we don't require you to do it yet. So, okay. So let's let's think about functions a little bit. So basically, when you let's just talk about it because it's in the slides. I mean, and I wrote them a while back, so why not? So the parameters are, so let's see. The top line of function is its declaration. In some languages, it's called the function's signature. A signature usually includes the function's name and like the parameter list, so like either the number of parameters or the parameters and the types if it's a typed language. The parameters are the variable names in the parentheses. So for instance, here you have a basic function that takes an integer, another function that takes a string and a list. Here's a function that doesn't have any parameters, and then here's a function that takes 3 integers or something, right? So the syntax requires a colon at the end. A function's parameters do not need to match the variables. So even if you say like a first integer, it doesn't have to be an integer, but of course if it's not, then that could cause issues. I think I should probably just not have said that sentence. Well, I mean, I should have said that sentence, but I should have said it differently. I should really say that if you don't do any type checking, if you don't do any safety checks, it's possible that something could get passed in that's not intended. So basically, if you're going to use some piece of functionality over and over, so for instance, if you're going to use like a take turn function multiple times, it's always good to put all that code into a function. So let's see. Let's write a function that takes a list of strings and splits it into a list of words. So I think what I mean by that is something like this. So let's write it out anyway. Let's say, if you have some piece of code that says like if we have some list of strings, some list, and so if we have a string in the list of strings, then what we want to do is we want to split it. So we're going to do a string dot split, and then we want to take each word. So for a word in the split string, I guess we say list of words. Yeah, I'll increase the font size. I'm not sure it can. No, I can't make the font bigger. It's impossible. Unfortunately, if it's blurry, then that's not really my fault. I mean, unfortunately, I can't control that. So, okay. So basically, if you have a list of words, you can always just do this dot append word. Yeah, that's if it's setting it to auto 240p or something, that's definitely not in my control to fix. And then we would, so here's a bit of code, and then the thing about it is that if you want to do this multiple times, then what you might do is you might just say, well, okay, if this is happening a few different times, then what we'll do is we'll just create a function. And then here we need to have the parameter, and then we can get rid of this one. And then remember that we have to return the list of words because we actually want that. So this is an example of how you would turn just a piece of code into a function. Basically, the idea is that sometimes what you need to do is you need to take the thing that's basically the input, and then it will do the bit of functionality, and then here, whatever you needed at the end of that piece of code, you need to return. So that's generally how to think about it. Okay, and so here you see kind of the, you know, a similar thing. Okay, so sure, I guess we can look at that piece of code. Alright, so maybe I'll skip the rest of this example just because, oh, you know what, maybe I shouldn't, because I think it's actually useful. So let's say that we define this other function called enter sentences, which is basically just taking in sentences. And so here we have two functions. I don't know. Oh, that's why it's angry. Okay. All right. And so the point is here, if we call enter sentences, and we print that out, then what are we going to get? Let's see what we get. This is basically going to make our list of strings for us. So essentially what you want to do here is if you enter, to be or not to be, once upon a time, and then I think, what do we enter? We enter quit to stop. And so what you see here is that, look at that. There's a bug in that code. The input's primed, but it's not appended correctly. The order was off. Interesting. Why don't we just fix that? Unless I intended for that. I probably didn't. So let's fix that bug. There we go. Okay. So let's try again. And so, but anyway, you see that here we enter the sentences. So this gives a list of sentences. And so the whole point of this exercise is that whatever comes out of the enter sentences function is a list of words, right? It's a list of strings, really. And so basically the idea here is that, remember that that is the return value. So what you can actually do here is you can feed a returned value into a new function. And so let me show you how to do that. You can say split into words, and let's print that. Enter sentences like this. And so what this is doing here is, oh yeah, that's a good point. So the idea here is that that you can feed one return into another function like this. So as soon as this thing returns, it's not going to remember what the return value was, but it is going to feed it into this split into words function. So let's, to be or not to be, once upon library, go. So here what you see is that the output from enter sentences was a list of strings, right? But it wasn't separated by words. And here, now, it's been fed into the split into words function. And so once that happens, it'll then run the split into words function on the result of the enter sentences function. And then that will then be output to the screen because that's a print statement. So basically your okay, so, alright, so basically, yep, there we go, there's some stuff. Function composition is what it's called. So, basically here we can split into words the list of sentences, and then you can say word list is equal to split into words, enter sentences, or you can even just do what I did, and just say print split into words, enter sentences. So, basically, let's talk about global variables and a little bit. The reason why I'm talking about these kind of like random little review topics is because file input output is usually a short lecture. So, yeah. So, when we talk about global variables, so generally what we're going to say is you cannot have any non-constant global variables. So what that means is that whatever you use inside of your functions, it has to either be a global constant or well, no. So it has to either be a constant or it has to be a local variable that's passed in. So for instance, let me show you what I mean by this. So if you have something, sure, a global constant can be a list. So how do they differ from magic values? Well, let me show you what I mean by a global variable. So here, if I have definition my function and I have x here, so x is a local variable because x is defined within the function. But let's say I define a value y is equal to 5 and then I return x plus y here. Now the problem with this is that it's going to return x plus y, but you see that there's no y defined in this function. So what that means is that Python is going to search for the global scope variable y. And so it will find it. And so if we say my function 3 and we print that out, then what we're going to see here is that, hopefully it'll run and not just error out or something like that. Let's comment this so it doesn't do. So you see here, this is kind of weird, right? Because you notice that what it did was it waited until it ran the function, and then since y was defined, it was able to actually do an x plus y. But so in this case, y is a global variable being used as a global variable. So don't do that. Don't do this. And so the answer is, like, if you have something like, for instance, if you, in your game you have player 1 is equal to, you know, Michael, and player 2 is equal to Rebecca. And I don't know why I picked those names or anything, but then if you say, like, you know, take turn or something, and here you say, you know, print player 1, it is your turn, right? And you do something like this, then you notice, what do you notice about the player 1 variable? You notice that player 1 is not being defined here. And so this is, it's kind of a problem. And the reason why it's a problem is because Python is going to use this global variable. And so I think if you do something like player 1 is equal to Sam, and then after, let's say, you know, we take turn, and then we print player 1. Wait, what's it doing? Unresolved reference player 1. Why does it not like that now? It was fine with it there. Let's run it, see what happens. Local variable player 1 reference before assignment. So here, I guess because it's doing this as a, so this is a local variable that has the same name as player 1, the global version. And so in order to use the global variable, you would have to, in this case, you would have to use the global player 1 keyword. And so, so you see that this is a problem, because what happens is that if you do global player 1, you print out the player, and then you modify the player is actually modified outside of the function, right? So we generally don't want to be doing this. So that's why the global keeper is forbidden in this course. And the reason is because we generally forbid global variables of this type. And so we don't want you to be using global variables and functions. If you want to be doing something like this, you should always just pass in the data into the function. And so here, now if you do this, we can take out this global keyword. We can take out the global keyword, and then what you're going to see here is, Michael, it is your turn, and then it sets the local variable to Sam, but remember that strings are copied, right? So strings are copied because they're immutable, and then therefore this player 1 is set equal to Sam, but this is the local variable, so this doesn't affect anything, i.e. the global version. And so let me just say that, like, the reason why we have you do this is because, in general, the idea when you write stuff, when you write code, it doesn't like it. You know, if we printed it out here, we could kind of show that it is actually changing the local variable, right? But it's not changing the global variable. And so this is actually the behavior that you kind of want. And the reason why is because, let me promise you that so many bugs, right? can be created by having all functions modifying the same global variables. And the reason why you can create a lot of bugs is because one function can modify a variable, and then you call another function, why is the player one highlighted? Because it doesn't like it. It's when it says shadow's name from outer scope. So let me just say what that means in PyCharm. What that means is there is a global variable, with the same name. I actually don't care about this. There's nothing wrong with this as long as you know what's happening. But yeah, so many bugs are created by having functions modifying global variables, and the reason why is because one function will messes with the variable, then the next one expects the variable to be in the prior configuration, and then kind of explodes. And so then what you see is that you see that the second function is the one having the problem, right? You think the bug is here, but really the bug was here. Yeah, so constants are an exception. Are technically global, but they escape. But the reason why we don't ban them is that they escape the problem that this bug is talking about, because you see that here you're not going to modify a constant, so this shouldn't happen, right? So because you shouldn't be modifying constants, so you shouldn't mess with it. And so this type of bug shouldn't happen. And so let me promise you that when you have a lot of code, and when you have a lot of complicated code, and you have a function that modifies a global variable, and then you have another function that modifies the same global variable, and maybe another function that modifies the same global variable, etc., 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 then if there's a bug in one function, you have to check every single function that modifies that global variable, because you never know which one caused the actual bug, because maybe the bug exploding in one function is, again, maybe it's a symptom that the function in, the symptom is that the bug is actually in a different function. And so, like, all of those functions are really just one kind of blob function that works together. And so, in a way, you don't want that, because the problem is that in life, you want to boil things down to very simple components that you can test. And if you can't test something because there's some global variable out here that if it's changed, it's going to mess up the test. So if it's right, then the test will come out right. But if it's wrong, then the test will come out wrong. Then you have to actually test this function along with this function. And you can't do something called unit testing. So the idea of unit testing is something where you test components, probably functions first, and then modules, basically on the way up. And so the idea of unit testing is basically that you should be able to test each component of your program separately. And so if you can do that, then basically you know that there's no problem with your global variables and all that stuff. If you can't test your program separately, and I mean, sometimes you really can't do it because there's some function that relies on the input of a previous function, even though there's nothing global. So sometimes it's very, very difficult. But it's like theoretically, can you test your components separately? And so that's, if you know one component works and then the next component works and then the next component works, then you hope that when you string them together, you have a working set of 3 components rather than just 3 broken components that each break each other in various ways. So that's kind of the trick here. Okay. Cool. So basically that's my spiel on global variables. For Project 1, since this wasn't really announced until now, we're going to be a little bit lenient. But like, what I'm going to say is that we'll be lenient, okay? We will be lenient about global variables this time for project 1, not for project 2. But, and on homeworks, technically, like on homeworks, in the past, almost everything was global. So we don't care. But let me just say, the reason why we're going to be lenient, but here's the one exception. So if you are using global variables and they're causing you problems, this kind of like error, then fix that, right? Take the global variables out, put local variables in. Well, so if you're declaring a variable, so the exception here is if you're declaring something, if you declare a variable in main and then send it into functions as a parameter, that's okay. We used to have like a main function, and that main function would essentially be like a kind of local scope for some of your variables, but you can't explicit, so that's the problem. No, so anything you declare in main is global, but just pretend it's not, right? Like send it into functions. And so this will also help you if you ever ask me for help, because when I look at a function, right? When I look at your function, I look at your parameters. If you are using something outside of the function that isn't defined in a parameter, we have to go hunting, right? And that takes a long time. It's confusing. Bad stuff can happen. So let's avoid that by making all of our variables, as many of our variables as we can, local. So yeah, if you change them without passing them in, that's using them as global. Okay. All right. So let's talk about functions. Or let's talk about file I/O. So, okay. So basically we have print and input for writing and reading to the standard in and standard out streams. Well, you have leniency for this project because I didn't say it until now. But if it's causing you problems, then I would change it, right? That's the moral of the story. If it's causing you problems and you want a TA to look at it, you should change it. It's actually usually not that hard to do. All you have to do is just add a parameter to your function that takes in the global thing and then just pass it in. And it's usually better because then you know that the thing that you're messing with inside of that function is in fact that object. So basically reading and writing to files, on the other hand, provides a way to store and retrieve data between program runs. I think that's a pretty obvious statement. Python handles files natively. So what I mean by that is that there's actually keywords in Python, like open, which open files for you, and there's an internal like file object in Python. Some programming languages don't really handle files quite so natively. They rely on like operating system calls and other kinds of weird stuff in order to handle files, but Python actually does it natively, so it has a file object. The Python will look for files in the directory that you're running the program. So that's something that's really nice. So you don't have to type out the whole path. Basically, if you just load a file, if that file is in the same place as your Python file, then it will, well, okay, I guess technically, if it's in the same place as you've called Python, right? So if you're in a different directory and you call a Python file from a different directory, then it will still look in whatever directory Python gets run in for that file. So we'll do some explaining of that. So opening files, how do you do it? So there is a function called open, okay? So open will open files. And so we have to remember the difference, right? So there's a big difference between no. So, well, I mean, we're about to get to that. So, okay, let's open a file. So let's create a text file. What's a good, what's a good file? Or what's a good thing? Let's see, Gutenberg. Okay, plain text. All right, here we go. Let's make a file. Do I want to add it? Sure. So this is a Project Gutenberg file, so it's just blah. Okay, there we go. So now what we can do is we can say open. And so that was, I almost accidentally did it just because I didn't type the tick mark. But remember that file names are strings. So I was seeing a number of people trying to type in just like basically into a function. They were trying to type like open or load board, you know, like project1 board1.csv, like that. Now this is an error, right? Because like what the heck is this thing? So what you need to do is you need to make sure that you type in load board string, right? File names are strings. Okay? And so if we open odyssey.txt, then let's say odyssey file equals this, and then we can basically just do for line in odyssey file, and we can just print out the line. And so let's do this and let's see what happens. Character map cannot decode blah 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 and character blah 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 blah. Wonderful. What have I done? Did I copy and paste some kind of horrible Unicode character or something horrible? I probably did. Okay. At position 6,000. So I guess instead of that, we'll just copy a single paragraph, which I'm pretty sure won't explode. So this kind of thing shouldn't happen to you unless, of course, what you're trying to open is a file that is has some weird character in it. I'm not entirely sure. I'm kind of looking through it right now. I'm not sure what the problem is. It might be these quotation marks or something. Okay, there we go. The point is not that we want to open up some file that's horrible. So here what you see is that, yeah, we could always try that, but I don't want to. So basically here what's going on is that each line in the file is outputting. So notice one thing about how file input output works, right? We're printing the line which automatically prints, right? This automatically prints a new line character at the end of the string, but each line already has a new line character. So that's something that's different about file input output. When you print a line from a file, it won't strip off the new line. So you see that this new line is right here, and then this is the new line from print. this is the new line from the file, this is the new line from print. Because if you see the original file, it doesn't have any of these extra new lines in it. Like, so the one way to print it like this is you could always just set the end to be this, and that would print it out as usual. And so the other way to do it would also be to just do line.strip, but that's taking white space off of both ends. So this is the other way to do it. You could do something like this. And that'll work. So, okay. Right. Cool. So what else do I want to say about any of this? Well, that's how you open a file. Okay. And so you have two options when you just open a file. So option 1 is you can read by line. And option 2, you can read the entire file. So let me show you option 2. So whenever you open a file, you also have to close that file. So let's close the file, and then let's open it again, because that's the only file I've created. And then what we can do is that there's a function called read. Can you edit the file? Not like this. So here's the file.read. What happens if the file isn't closed? That's a good question. What argument goes in the close? Nothing. It just closes. So, and I guess technically, if I'm closing files, we should not close it. Okay. So you see here that we should see it twice, right? And this difficulty attaches itself more closely to an age, which blah, 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 blah. And then here, and this difficulty attaches itself, right? So this is the second printout of the thing. The problem that happens if you don't close a file. So what happens if you don't close a file? The answer is, generally, in read mode, nothing. And we have opened the file in read mode as we have used the read function on it, or we've done the for-line in Odyssey file, which is also calling, this is calling Odyssey. Basically, I'll show you Odyssey file.readline. So there's a function called readline. And so generally nothing in read mode. It does, so basically what the operating system does is it creates a what's called a file handle, which is like a number or a code or an identifier that basically tells you or tells your program which file it is that you've opened. And if you don't close it, then that handle just sticks around, and it can actually stick around past the lifespan of your program, because the operating system, sometimes when your program ends and you haven't closed files, it'll close them for you. And sometimes it just, especially if your program crashes, it will just like leave that file handle there and it just won't close it. So sometimes the file handle isn't closed. The main time that this is a problem, so the biggest problem is when you are writing to a file. And so the problem with writing to a file is that operating systems like Windows and Linux and Mac OS, because it's Linux, and Unix basically every operating system I'm currently aware of, what it does is it locks a file based on the write permission. Generally what it does is it prevents multiple programs from opening a file with write permission. Because if you have two programs that both open a file with write permission, you'll see that this is not a good thing. And And so operating systems generally prevent this. But then you would ask, well, what happens if my program crashes while my write permission is open? And the answer is sometimes the OS forgets to unlock the file. So I don't know if you've ever opened a file or tried to open a file on your computer, and like it, especially, I find, as bizarre as this is, it usually happens with the MS Office package. So whenever I'm using Microsoft Office, so like Excel or Word or PowerPoint or whatever, which I haven't used in a long time, but whenever I did use that, it put a lock on a file, and whenever you tried to open that file after, say, Word crashed, it would then not allow you to open that file again until you like either restarted your computer or waited for the file handle to close. So can you close it from the task manager? Generally not. I guess what you could always do is, if you knew what the file handle was, you could actually open up a new program that ordered that file handle to close. But the point is, you're not going to really be doing that. That's some trickster nonsense. So so the point is that so what happens if you don't close a file? Generally what it's going to do is it might put a lock on a file and you can't use it again. Until you either restart or, you know, it magically unlocks for some reason, like the OS forgets that the... yeah, so, I mean, there's a lot of stuff like that. So basically, file permissions are one of the biggest things in file I/O. So now that I've talked about what happens, let me talk about... let me do the other... So we've seen read. So read exists, right? You can read the entire file. So if you're wondering what this does, this reads the entire file at once. Okay? With end lines all the way to EOF, which is end of file. Okay? So basically here, this thing reads the entire file at once. This reads it line by line. You can also call, so basically, let's do it again. Let's open and then what we're going to do is we are going to say while keep going. Why don't we just do while input do you want to keep going dot lower dot whatever, maybe dot strip is in y and yes. And then what we'll do is we'll print out Odyssey file dot read line. And so I guess just to be safe, we'll do Odyssey file dot close. Not that. So reading, again, reading is not usually the thing that causes the problem. It's normally writing, but whatever. So here we go. Do you want to keep going? Yes. Here's a line. Do you want to keep going? Yes. Yes, 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 yes. Right, so this will output the file line by line, and then finally if I say, not really, then we're done. Okay, so this is the way to output the file, line by line. So, okay, and then there's one last command. So you don't need the R, so I haven't gotten that yet. Yeah, yes, it is automatically read. So let's do it one last time. For the project, y and yes should be constants. Yes. So let's do one last thing. So I want to print out read lines. So what is the difference between read line and read lines? Well, presumably, if everything makes sense, read line should read a single line, and read lines should read all the lines, or at least some of the lines. So let's see what happens. Yes, 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 no. And so what you see that happens here is that this last thing that happens after this while loop runs, after we've closed the file, we reopen the file, So basically here you see a list now, right? Here's a list of strings. Each string is basically started with, well, whatever it is, and it's ended with an end line. And the end, remember that the end lines stick around in these strings, so basically that's what you end up seeing here, right? There we go. A sinecurist. That's an interesting word. So there we go. And so basically you see that each one of these strings ends with an end line, and all of the lines are red. I guess there was no trailing end line in that file, so if we look at it, we should see that there's no trailing end line, right? There's no way to go to the next line. If we have a trailing end line here, then that would be there. So basically, yep, so this reads the whole file. So readline reads every file, but it returns it as a list. Tawdry. Oh, tawdry. Doesn't it mean like kind of a little naughty, illicit, let's see, showy but cheap and of poor quality. Okay, tawdry. So I was a little off. So, okay. So, okay, cool. So we've opened and closed this file a bunch of times, and we've read and read and read, right? So now you theoretically should be aware that there's a read function, there's a read line function, and then there's a read lines function. So read returns a gigantic string. Read line returns a single line, generally with an end line at the end, though maybe not if it's the last line. And finally, read lines is going to return a list of read line. Okay? So okay. Cool. So we've opened files. I don't know. I think you might be able to. I mean, I'm not sure if it's going to check if the word is in the file or, like, so if we say if difficulty is in Odyssey file, print yes. I'm not sure what this is going to do. I think this might not work. Else print But I could be wrong. I think this won't work. So let's say no, we don't want to keep going. Yeah, it didn't quite work. Now if we do something like this and we say this whole thing is in Odyssey file, this might work. No, we don't want to keep going. And so what you see is that if it's an entire line, then it will work. If it's not an entire line, then it won't work. Because remember that the things that are getting returned to you are the lines out of here, not the individual words. So I would be, honestly, I would just be careful with this. It's not illegal. It's just a little scary. Yeah, now if you did that, that would certainly work. So if you did, so for instance, if you did something like, let's close the Odyssey file again, because we are being fastidious, and then if you say, if difficulty is in Odyssey file.read, we print this will definitely work. I guarantee it. And if it doesn't work, then oops. Let's see. No. Yeah, so this will definitely work. And actually, this is kind of what I prefer you do, because what this does is it'll read the whole file in. And so also what you can do is you can say Odyssey, like file contents, and then you can just use those file contents over and over. Let me also say what happens if you try to read a file again. So basically, does close take it out of the program memory? Close closes the file handle in the operating system. So it basically tells the operating system, I no longer want to read or write to this file. Okay? So, okay, so what if I did Odyssey file dot read line, print about to read another line, like this. Like, what if I did this? Could you print the file context? Yeah. Yeah, you could print this as a string. Man. So basically what happens here, right? So notice if we try to read another line, I didn't close this file. So what happened here? So yeah, what happens if we do this? And you see here, it's about to read another line, and then it prints out nothing, right? So why did it print out nothing? And it printed out nothing because the cursor, so there's a pretend file cursor in the file. So basically, once you read the whole file, like once you read a line, your cursor will be here. And then once you read the next line, it'll be here, and then here, and then here. Once you read the whole file, your cursor's at the end of the file. There's ways to move the file cursor. We are not going to be discussing that in this class, at least not the, no. So maybe you'll talk about that in 202, not here in 201. So, but the point is that if you try to read another line, what's the next line here, right? There's no additional data in this file. So that's the point here. So that's why it comes out blank, right? It comes out blank because we already read the entire file. So no more data. Okay, so that's it. All right, so let's do Odyssey file.close for the last time. And then let's copy and paste all this code into Odyssey example. Okay, so let's define a function called Odyssey example. And then let's not call this function. Okay? Instead, now I want to talk about file writes. Okay? So let's talk about writing files. All right, so here's how to write to a file. So you can open a file, and let's call it newFile.txt. And here, now you have to use a second argument. So when you want read permissions, this is what you do, right? You use the R option, or you just leave it blank, right? So this is read, or technically you can leave it blank. By default, it is read permission. And you'll see why in a second, because write permission is kind of a little bit scary. So new file equals this. So this is our new file. And so what we're going to do is we're going to do a new file.write. So unlike, so let's do new file.write. And then we're going to write something. So let's say let's say while s is not equal to quit. And of course, now you're going to be like, what's s? S is equal to input, enter thingy, new file.write s, and then we will input a new one. And at the very end, Now we should be a little careful. New file.close. Okay. So let's try this out and see what happens. Okay. So enter thingy. Hello. And let's see what happens. So where is the new file? New file should be created. Come on. Show me a new file. Show me the new file. Where are you? Alright, I'm just going to look at it in the directory. Let's see here. Yep. Okay, let's see. Maybe? So here's the new file. Alright, so let's see what happens when we write things to new file. So hello, goodbye. Writing to files is fun. Here is something to write. So we look at this file, and there's nothing in it. So then let's see what happens when we type in quit. There we go. So, okay, so what's the problem with what just happened here? So there's two problems. That's a good question. So let's try it again. So the question that was asked is, will the W option append or overwrite the entire file? And so here's the answer. It blanks out the file. So basically, whenever you use the W option, so now we're going to enter something, ASDF, I guess Sam, Michael, robots, happy, gaudy, tawdry, sinecurists. Yep, now ends the bloody business. Of the day, quit. And so what we see here, so there's something that's still a problem. So we see that when we write to a file, it does blank out the entire file. So that is potentially very bad, right? So if you use the W option, you have to know what you mean by using the W option. You cannot just like use the W option willy-nilly. Okay, so if you're going to do this and you're going to try to open a file, make sure that that file is either blank or you really don't care about what's in that file because it's about to be deleted. So yeah, whatever's in that file is about to die. What's the other problem that we see here? So remember when you read from files, there's no new line characters, or there are new line characters that are not removed. And here, when we write to files, is there a way to append? Yes, of course. When we write to files, got myself. Excellent. So, okay. But what's the problem here, right? What's the problem here? Well, this isn't usually what we want. What we want is something that's more like this, right? And you see that what file IO does not do for you is it doesn't put in, like print does, right? Print has an end statement where it'll put in an end line at the end of your thing. This does not do that. So what you have to do is basically add an end line. Yeah, so that's actually not a bad way to think of it. W is like create or overwrite, right? So W is not just write, but it's like create and or overwrite. Okay? So it'll create the file or it'll overwrite the file. So anyway, let's try this again. What does the S do? So Yeah, so there, as it turns out, there was no new file.txt before I called open on it the first time. Okay, so when I called open on it the first time, you know, it'll just it'll open it. So hello there. Here is a string, and so the other thing to notice here is that if we actually open this, oh, I guess it's not doing it. So why won't it do it? I'm sad. Yeah, so sometimes you'll actually see it overwriting in the file in real time. Let's see if we open this in like, no, it's not writing to the buffer. So the way to think about it is that when you do a write, write sticks the data into a buffer, not a bugger, a buffer. And then whenever the OS feels like it, it will dump it to the file. Okay, so there's ways to kind of force it to do it, but let's not even get into that. So here, now you see that there's nice end lines on the end of every input, and so that's what we want, right? So if you're going to be inputting lines into a file, generally remember that the end line character, when you read the file, it's not removed, and when you write to the file, it's not added. So you can theoretically write Python files with Python. That is true. That is true. You could actually kind of write Python code with Python and then execute it. Can we open and close in the loop? Yes, but that's scary. Like if you actually opened the file in the loop and then wrote something to it, what it would do is it would overwrite the file every time. So I don't know really that that's ever really what you want. Okay, so let's say wow, you're not demanding. So oh, I see. Can we open and close the file in the loop and use append? The answer is if you use append, you don't have to keep opening and closing it. You don't want to be doing that. So opening files is something where you have to request something from the operating system, so you don't want to be like constantly opening and closing the same file. If you can, you want to keep a file handle open and then write to the file everything you need to and then close the file. So okay. So all right, let's do it again. But this time, let's append. Okay. So yeah, basically the reason that I'm doing that all over like so many times is I'm demonstrating that I want to move the cursor back to the beginning of the file over and over and over again. Now for read access, again, read access, it's not so bad. For write access, right? If you're opening and closing it a bunch of times, occasionally the operating system, especially if it's Windows, may just glitch, and it just will forget that you've closed it the previous time and then just not reopen it. That does happen occasionally. And sometimes it's not even your fault as the programmer. Sometimes the operating system is just like, I don't know what's happening, I give up. So, all right, let's do some more stuff. And then let's do new file again, .close. So, let's do this. Let's enter in some movies. So, I was watching The Fifth Element last night to cheer myself up. And then there's The Matrix, which ain't bad. Gladiator was one of my favorite movies in high school. There's always Blade Runner. There's Frozen, I guess, because people watched that. Everybody was talking about that for like 3 or 4 years. Oh man, whoa. That is the best movie of all time. Therefore, we will now quit. Okay. So, what did this first quit do? What this first quit did was it closed the file. So now we have a file that has all this stuff in it. And now we've reopened the file with append mode. And so append mode, right? So sure, mag 7. Oh Lord, what have I done? Ah, I didn't. Okay, oops. Notice that this was new file and not new file again. Well, actually, that's good, right? That's good because, so it's good that I did this because now you see what happens if you try to write to a closed file or read from a closed file. It's going to be like value error, IO operation on a closed file. Don't do that. Okay, so let's try again. Okay, so let's enter some more stuff. Manos, Hand of Fate, Matrix, Matrix 2, Matrix 3, Matrix 17. Oh, what else? No idea. Quit. Okay, and then, yeah, so now we should be in the append mode. So here, let's see if it will append Shrek, Shrek 2, Shrek 3, Shrek 4, Shrek 5, Shrek 17. I don't know. Yeah, you know, on the matter of my hair, I haven't had a haircut since the pandemic started, so it's getting slightly out of control. It's just extreme. I might even be getting like a mullet in the back now. It's terrible. And yeah, anyway. So whatever. So what's another Blade Runner? Ooh. Okay, Star Trek. Star Trek 2, Wrath of Khan. Alright, so now I'm going to quit. And so you see what's currently in the file, right? It's the crap that I typed in initially. And now we are going to quit and hope. There we go. So, Star Trek. Yeah, it's not bad. Not bad. So this is basically what happens. So you see that append mode, and then if we don't open it with write mode again, if we open it with append mode now, then what's going to happen is we can say ASDF, 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 quit. And so here you see the ASDFs. And then let's see, Shrek Trek. What's that movie? Galaxy Quest. Oh. And what's another good movie? Spaceballs. And sure, whatever we can think of. Emoji Movie. You know that had Patrick Stewart in it. Alright. I never actually saw that one. Okay, now I'm going to quit again. Sure, Monsters, Inc. Now I'm going to quit. So, there we go. We see that at this point it's appending. Alright? So those are the 3 file modes. right? So to recap, the read mode is read mode. The W mode is write mode, but remember that's really an overwrite mode. So append, I think, will also create the file, if I'm not mistaken. Let's try to do a new file too, and just see what happens. So, okay. All right, so as it turns out, append will also create the file. I thought so, right? So there are reasons to use write mode. Sometimes what you want to do is you want to have total control. You want to just take whatever's in the file and rewrite it with exactly the data that you want to output. And in that case, you want to do a W. If you have like a log or something, generally logs are opened in append mode, because the thing is, like, you don't want to delete the prior log, you just want to add to the log, right? So if you have some program that's logging behavior in a file, the reason why you log behavior in a file sometimes is because if your program ever crashes, you don't actually have all the data from that program anymore. But if you log what's happening while the program's operating, then at least the last thing that you logged in the file will hopefully be like the last thing that the program tried to do before it exploded. And so then you can know where to look. And so that's why log files exist, is because especially on like servers, when you just have a program that's like running on a server, you don't necessarily know, when it crashes, you're like, okay, what happened when it crashed, right? All right. What else do I want to do? I think that's it, right? I've done file I/O. I think I've said everything I want to say about files. Oh, the next time what we'll talk about is the with keyword. So I didn't talk about with this time. So to finish up, next time we'll talk about with, more file stuff, and then we will do stuff. And by stuff, I mean probably more recursion or classes. Yeah, we've added with to the class. I always talk about with is. I'll explain it next time. I don't want to talk about it right now, because if I talk about it, it's like a 15-20 minute topic, so let's just not. Anyway, I think that's about it. So, oh, I totally forgot, and maybe I'll announce it here, because I'm so nice. I'm going to make the building of buildings and the building rent part on your project extra credit. So for project 1, building buildings and building rent is going to be extra credit. So get the rest of the project working before you do this. Okay, and so my feeling is that I'm probably going to make it like a plus 15 points or so. So the project will be it'll be 115 out of 100. So so there is an opportunity to get some points there. Also, I just wanted to scale back the project. I'd kind of been intending to do this for, I don't know, a few days now. But I just kept forgetting. I was going to announce it last night via Blackboard, but then I forgot. So I'll send out a Blackboard announcement now. All right, I think that's it for the day. Okay, that's all, folks.